Hello everyone, welcome to this presentation. My name is Jing from Federation University, Australia. Today I'm going to talk about a topic, the significance and impact of winning an academic award. It is a study of early career academics. Anything that cannot be solved in this presentation, you can contact me in this email. Okay, my presentation will be followed as the following 4 parts. First, I will show you some background information of big scholarly data. Next, I will propose 3 research questions and the corresponding method we used to solve these questions. Next, I will show you the experimental results, and finally, I will give you a brief conclusion. Okay, the first part is the background information. From this figure, we can see that big scholarly data is mainly composed of 4 parts: researchers, their publications, published venues, and institutions. And also other informational features like researchers or scholars have features like education experience, academic impact index like H-index, as you may know. So they collaborate with each other, publish papers in conferences or journals. Also, each researcher is affiliated with at least one institution. Each item shown in this figure can be ranked or evaluated from the perspective of academic capacity. Okay, this paper chose the award named the National Science Fund for Distinguished Young Scholars. This award is set by Chinese government, and all applications should be under 45. The award will support about 160 outstanding young scholars each year, and the support year is about 4 years. So this means all projects should be finished in 4 years. Okay, the author list we select is between 2000 and 2011. Someone will say the time is a little bit old, but there are 2 reasons. The first is that due to some privacy rules, the author list in recent years has not been published. The second is that we have to evaluate the academic impact of scholars after winning awards for about after 5 years. So if we select scholars in 2019, we cannot evaluate their academic impact after like 5 years. Okay, so other information like their publications are downloaded from the website, the Web of Science. This data set automatically divided the research fields into 13, like computer science, biology, and arts. Okay, next is the research questions and methods. First, how do early career academic awards impact on recipients' scientific impact? Second, do this award improve the recipient's work performance? And last, I want to explore whether early career academic awards affect the recipients' teams and their collaborations. So it will be studied from the perspective of team size and academic performance. So first, we have to construct control groups for the treatment group. The first step is to select characteristics, and the following indicators in the last 5 years before winning awards are selected as control variables. The second is to use the binomial logistic regression model to estimate the parameters of the relevant impact factors. The coefficients of the model are obtained by the following equation. Here, P award is a propensity score value, denoting the probability of winning award, and X is a vector representing the characteristics, such as the number of papers, found papers, blah, 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 blah. After getting the values of parameters alpha 0 and alpha 1, the propensity score of each researcher can be calculated by this equation. According to the propensity score, the control group is selected as the object closest to treatment group. Academics in the treatment group are recorded as S equals to 1, well, vice versa. So the difference between these two groups are defined as this. Okay, according to the propensity score, the control group and the treatment group are matched at 3 levels, namely high, medium, and low. Finally, we conduct a significance test for the two groups' characteristics. The matching model will be established when there is no significant difference between these two groups. So here we select the analysis of variance. And next I will show you the results of the NOVA. Okay, here, table 1 shows the results of the analysis of variance. Each value of f will correspond to a p-value. Small value of f and p means that we can accept the primary assumption is that the samples between the control group and the treatment group are so similar that they could be compared in terms of these indicators. It should be noted that the sample size of the treatment group and the experiment group are so large, so we classify the scholars into 50 groups. Here, Table 2 shows the results of logistic regression model. If the value of p is less than 0.01, then it means this indicator has significant relationship on the award results. The first row regression coefficient refers to the positive or negative relationship on the award results. So we conclude that the number of papers, average citations, and total citations have positive relationships on the results, while journal impact factor have negative relationship. The number of found papers and each index have no significant relationship on the award results because the p-value is more than 0.01. So based on the indicators selected in the first step in here, based on these indicators, we propose a metric called award change factor. Taking the number of papers as an example, we qualitatively fit a piecewise linear function according to the number of papers over time. Here, M1 and M2 are slopes of two fitted lines showing the productivity changes before and after the award. Here, T denotes the time of winning the award. So if T less than 0, it means before award, and here after award. By fitting these 3 parameters for the production, the ACF is defined as the difference between M1 and M2. When ACF is more than 0, we consider that the award has a positive effect on the academic. Here, to estimate the effect on scholars, we propose 2 models. The first one is whether awardees have higher impact than scholars without. And the second one is whether scholars with higher probability have higher impact than scholars with lower probability. In both models, we aim to get the value of alpha, and the value of alpha will help us answer these questions. Okay, and next we want to estimate the effect on academic teams. So here we propose another metric named collaboration intensity between scholar I and scholar G. Here, delta T means the interval of years measured, and FQ denotes the number of the author I and J co-authored in the delta T year. Next, N denotes the publication number of I and J during the delta T year, respectively. Here, The higher the CI value, the closer the collaboration between two scholars. Okay, next I will show you the experimental results. Here, Figure 1 is the average value of each index in the 5 years before and after award. We can see that the average value of each index shows an increasing trend over time. For each index, the value in the last 5 years is higher than in these 5 years. So it can also be seen from the figure that besides the average citation and the journal impact factor, the number of papers, found papers, and the H index of scholars have increased significantly after receiving awards. Here, Figure 2 shows the changes in the slope. This is obtained by fitting the index value before and after awards. So here, the value in the left line refers to M1 and the right line represents M2. Here the scholars are divided by research fields and the green or red lines refers to an increasing or declining trend. Here, Table 5 and Table 6 answer the two questions we just proposed for research question 2. In Table 5, we can see that the coefficients of low and medium probability academics in the control group are significantly lower than those in the treatment group. But the coefficients of high probability academics in the control group are slightly higher than those of academics in the treatment group. So alpha 4 are more than alpha 2, alpha 1, but less than alpha 3. These results show that compared with the middle and low probability academics, the impact factors of the academics in the treatment group are higher, indicating that awards do have positive effect on academics. The second question is whether high probability academics in the treatment group have higher scholarly influence than the low probability. We can see from this table that for the treatment group, the coefficient of high probability academics is obviously higher than that of medium and low probability academics. And the coefficient of medium probability academics is higher than that of low probability academics. So we can conclude that the higher the probability of winning award is, the higher the output and influence of academics is. So for the control group, there are similar cases of the parameters. Okay, the last question is how do early career academic awards affect their teams and collaborations? Here, figure 7 can show that the citation, paper, and the journal impact factor all show increasing trend after winning award, no matter in which kind of calculation formula. Well, Figure 6 shows the proportion of academics whose parameters increase or decrease. The first 3 rows show the number of awards, the next 3 rows refer to their team members. In summary, the recipient of an award has a positive impact on most recipients and their collaborators. Okay, let me give you a brief conclusion. Most scientific indicators like paper and citation count will increase after awards for both recipients and their teams, just shown in the above-mentioned experimental results. And academics who have a high probability of winning awards but who have not yet perform even better than award recipients in terms of both paper and citation-based indicators. So we can conclude that awards are not the only motivation to encourage academics research. Okay, finally, I want to acknowledge the JCDL student travel grant for the cover of registration fees. And are there any questions? That's all that I want to share with you. Thank you.